Can you hear like
Yeah.
the talking in the background? No?
Yes, I can hear you.
You can? Okay.
I
Let
can
me
hear
see.
you, but
Oh, you
we started
can hear me, but
broadcasting.
yeah. All right.
Yeah, maybe we can wait 1 or 2 minutes.
Sure.
I think there
Yeah.
will be more attendees to join.
Yeah. I guess we can start. Hi, everyone. Hopefully you can hear me. I hope, please let us know if if you're unable to hear us in the chat. Hi, I'm Monica Madila. I'm one of the organizers of the NLP seminar. We are really excited to start our NLP seminar this semester. And the idea is that we'll get to hear NLP researchers talk about their work, both students and faculty, while having lunch. So we have a seminar. We have like 6 talks this semester, and it's once in 2 weeks, 12:30 to 1:30 on Friday. And we have a wide range of topics. So hopefully you will like the talk. And then one more thing is I understand that we are virtual and difficult to interact, so please put your questions either in the event chat or in the Q&A chat. And then we'll collect all the questions at the end of the talk and then ask the speaker. So let's welcome our first speaker for this semester, Lara Martin. She is currently a PhD student here at Georgia Tech, and she will be presenting her work on automated story generation. Basically, how do you teach machines to tell stories? I think it's a really cool topic. Looking forward to the talk. And she's the recipient of 2020 Computing Innovation Fellowship Award and will be now joining Professor Chris Callison Birch's group to continue her work on story generation. So I'll hand it over to you, Lara. And yeah.
All right. Thank you so much. And yeah, thank you for inviting me to do this.
Yeah.
So I'm going to be talking about Dungeons and Discourse using computational storytelling to look at natural language use. And I would normally say feel free to ask me questions during the talk, but I can't really like see the chat. So unless like maybe one of the are you moderators? I don't know.
Yes, yes,
Yeah,
we're one
so
of the
one of the
moderators. Yeah,
moderators would like to kind of go through the questions and read them to me. That's fine.
yeah, that
It's
sounds good. Yeah,
whichever way. Yeah.
yeah, that's all.
All
I
right.
think like once the talk is done, we'll just collect the questions and we'll ask you the questions. Yeah.
Okay, at the end. Okay, sure, that works. Okay. All right. So, conversational agents like Alexa and Siri are ubiquitous because communication is important to humans. However, these systems don't actually know how to converse. So what's going wrong? Well, some of the things that are wrong with Alexa are she lacks a long-term memory. Sorry, I realized I didn't mute her, so I'm cautious. Uh, she can't continue a conversation. She lacks storytelling and creativity, so she's more repetitive and less engaging. And she lacks an emotional understanding, so she can't sympathize or have compassion. And these are just a few things. But if we know all this, why isn't it solved yet? Well, these are actually really hard problems. And so let's look at how people talk and some of the hard problems in natural discourse. So in natural discourse, there's an infinite number of sentences, and people can say whatever they want. There are unexpected consequences. So I can't predict how someone's going to react to something that I say. We live in a dynamic and continuous world. So this is a messy world that can't easily be turned into discrete states like computer scientists like. It's also a distributed world. So people rely on their own experiences of the world, and we're constantly creating our own idea of what the world is like. And we also have ideas of what we think other people think of the world, known as the theory of mind. And there's also an intrinsic reward. So sometimes there's extrinsic reward, and that's like like a couple people sit down and they have a clearly defined task that they're working towards. But sometimes there's an intrinsic reward, and you're just getting enjoyment out of the thing that you're doing or the conversation that you're having. And it's also collaborative. So people conversing are often working together towards a shared goal, even if it's just like figuring out where to eat for lunch. And everyone bringing something different to the table. So I know what you're all thinking. These are also things in Dungeons and Dragons. Well, you probably weren't thinking that, but unless the title gave it away. So if you weren't thinking that, you might be asking, what is Dungeons and Dragons? So Dungeons and Dragons is a fantasy tabletop role-playing game with a DM or dungeon master, and this is someone who referees what the players do and creates the story world. And also, costumes are optional. But also, it's planning and acting through dialogue and collaborating to tell a story. And both of these can solve some of the same problems I mentioned in the previous slide. So in the rest of the talk, I'm going to discuss my work on pushing the boundaries of modern story generation techniques. And then I can talk a little bit about some ideas for future work. The story generation. So why am I talking about storytelling? Well, storytelling is one of the most natural ways that humans have of communicating. We've been telling stories since before we could even write. And we are constantly telling stories about everyday life. So I could tell you a story about how I'm teaching my dog how to speak using these buttons. And one day he got so excited about playing that he ripped the play button off of the mat. And so when I tell you that story, that tells you things about me. That tells you that I love my dog and that I'm interested in language. But it also doesn't tell you things. Like I don't have to reintroduce what happens when you tear something off of something. So the question is, what if computers could tell stories? What would this enable them to do? Well, they could entertain us. It could say, Alexa, tell us a spooky story about the Jersey Devil. Plan with us.
The legend of the Jersey Devil came to your screen.
Alexa, stop. Plan with us. Bixby, what makes for a good party? Teach us. Siri, how do I bake cakes? Prepare us. Cortana, how do I ask this guy out? And support us. Hey Google, I just broke up with my boyfriend. So this is not new. This is the field of automated story generation, which is teaching people, teaching computers to tell stories. But some of the first systems are pretty simplistic in that, like, you end up with stories like this. You have one day Joe was thirsty. Joe wanted not to be thirsty. Joe wanted to be near the water. And more recently, there's a story like this, and I can wait for a few seconds to let you read it, but basically it's a story about how you ask a knight to kill a sorcerer who ends up being your father, and then the king knights you. So as you can see, the more modern one is a little more sophisticated. So how are these stories made? Well, these stories in particular were formed using causal chains. So here's a very linear, exciting example of someone picking up drugs at the pharmacy. So you start off with standing in line, and then at the end, the customer leaves with the drugs. And these causal storytelling systems are usually made with very specialized knowledge engineering. So someone had to sit down and handcraft this chain. And you can look at the individual links, which is interesting, and you can see how, like if we zoom in on this one, oops. So it's like, how do we go from standing in line to the customer leaving with the drugs? Well, we need to look at like all the individual steps. The pharmacist asks, how do we go from pharmacist asks for a prescription to the customer produces the prescription? And so in order for the agent to do this, they need to query the world to see if the customer has the prescription. Is this a fact in the world? And if they do, then they can go on to the next state. And you can also create longer-term causal links. So in order for the pharmacist to deliver the drugs, the customer has to produce the prescription, and so on. So some of the pros and cons of these causal chain models are that they're really coherent, so they create stories that make sense, but you need a lot of knowledge engineering to make them, and they possibly lack diversity and novelty because you have to come up with every single step. And so this creates a limited domain. Like with that previous chain, I can only tell you stories about picking up drugs at the pharmacy. But the dream is that I want a story prompt, so the first sentence of the story, and I feed it in, and then I'll get the rest of the story out about anything. And people have been working towards this shared dream using neural networks. And so how neural networks work are you have a ton of stories, you train a neural network on them, and when you run the neural network, you get a story out. It's just like a really generic story. And one of the issues with this is that if you feed an input that it's never seen before, it often doesn't know how to react. And to demonstrate this, I'll show you an example of how some people took a bunch of science fiction movie scripts and trained a neural network and then decided to film it. And I'm going to move my mic over to the screen that's playing it, so hopefully you can hear it, but if not, it has subtitles.
Future with mass unemployment, young people are forced to sell blood. Good boy, shut up. I was the one who was going to be 100 years old. I saw him again. The way you were sent to me. It was a big, honest idea. I am not a pipeline. Well, I have to go to the skull. I don't know.
All right. So yeah, it's a pretty bizarre little clip. At the end there, in case you were curious, the script said he picks up a light screen and fights the security force of the particles of a transmission on his face. So to recap, causal systems can create nice coherent stories, but they're limited in domain, where neural network systems create unique stories, but the coherence is terrible. So what if we want both coherent and unique stories? Why can't we have both? So I'm going to show you how I go into combining the two. So first I'm going to talk about how far can I push these neural models to make them better. So a typical neural network behavior, like a sequence-to-sequence recurrent neural network, behaves like this. So this one was trained on movie plots from Wikipedia, and so if you have the sentence R2D2 carrying some drinks on a tray, strapped to his back, passes Yoda, who uses his force powers to hog the drinks. What you expect, and what was the original next line in the story, is Obi-Wan and Anakin are drinking happily when Chewbacca takes a Polaroid picture of Anakin and Obi-Wan. But what you get instead is, Ken this block gives him the advantage to personally run around with large stick of cheese. So the grammar is okay, mostly, but the meaning doesn't fit at all. But what if we just make the model bigger? So you might have heard of GPT-2 and now GPT-3. It's a huge language model called a transformer, and it's known for being really good at generating text. But is it really that good? So here I tried, this was actually my first time trying to speak with a transformer from the site Talk to Transformer. I put in the line, the hungry dog licked her lips as she watched her owner eat, and this was the story I got out. She could see the white teeth in his jaw, then moving behind his right ear. The hunter picked up his sword, directing the dogs in a cloud of mutterings. Did you just feed a dog? She demanded, suddenly even more agitated than before. Yes. Jack's voice was rough, and he hated that word. His face was tight and angry. She has killed something important to us, and now the house is filled with blood. It makes me sad. She is one of the most dangerous wolves I have ever met, and if she bites me, she will lose. John shrugged. Well, it's not your fault, he said. So it's certainly still interesting, but even these large models are still losing coherence. So why is this happening? Well, one of the issues is that, like, if you have a sentences like R2D2 carrying some drinks, it only appears once in the entire data set. So what I did to combat this is I separated the semantics, so the meaning, from the syntax, the grammar. And that way you can get more overlap in the data and see more patterns. And I did that by creating event representations. So I used my linguistic knowledge to bootstrap the neural network, and I created this event representation, which is, you can kind of think of like as a baby sentence. It's subject, verb, direct object, and a modifier. And so if I have the sentence, Yoda uses the force to take apart the platform, I can get the event, Yoda use force, empty parameter. And then I can actually further create more overlap in the data by generalizing these events. So I can turn it into person zero by using named entity recognition. And I look use up in VerbNet and I come up with a fit, and then I look force up in WordNet, which is a hierarchical dictionary, and I get power. So now I have events. How is this how does this work into storytelling? Well, so I have this giant pipeline where the user gives a sentence like John unwittingly unleashes an insidious pox. I eventify it. That becomes person 0 disassemble contagious disease. And then I train a sequence-to-sequence neural network to generate the next event in the story. And then it'll give me something like male spatial configuration adopt, empty parameter adopt. And then I can loop this around and get the rest of the story. And this actually, the more I generalize it and more eventness I use, the complexity goes down. Where perplexity lower is better. And perplexity is a standard way of measuring language models. And it's basically saying how surprised is the model by this new testing data. And so now that I have these generated events, how do you read them? So I throw in another sequence-to-sequence neural network, but I keep things generalized, which I'll get to in a second. So the generalized sentence that comes out of this is male crimples and is about to be sheath. And so when I generalize these sentences, I get better blue scores. And blue here is a little more appropriate because it's often used in machine translation. And you could think of event to sentence as a machine translation task. So now I have generalized sentences. Why am I keeping them generalized? So let's say I have a whole bunch of cat stories, as one does. And I train my generalized event-to-event model. But now when I'm testing it, I put in the sentence, the dog was digging in the yard. Well, because it's generalized, it doesn't freak out, and it can then spit out carnivore eat animal tissue. But I'm saving these tags, so carnivore now refers to dog in this particular story, so that it becomes the dog ate the bone. And so I can keep all these tags. Person 0 is John, contagious disease is the pox, and I can fill the sentence in, and it can also fill in new entities that it sees. And then I can get my sentence out, which is he crumples and is about to be husk. So we have a sentence, but there's still a problem with this event-to-event model, especially the sequence, because it still veers off into like a stream of consciousness. And part of the issue is that it's thinking about the past and not about where it's going. So next I looked at plot progression and trying to coax the model toward a goal. All right, so oftentimes we have a series of major plot points in a story. Let's say we have a romance story. The characters meet, there's unrequited love, but then they admire each other. Then there's some terrible discovery, but then there's an understanding, and then they get married in the end. So how do we make sure we hit at least one of these major plot points? Well, zooming in on the event-to-event loop, I created a policy gradient deep reinforcement learner. So I took the sequence-to-sequence model and I ran it to see, okay, is it heading towards my goal? So is it getting me closer to the characters getting married? And then depending on how it does, I feed it back into the network, back propagate it, and it will basically retrain the network. And so how do I compute whether or not it's heading towards the goal? So it's in two parts. One is there's verb distance, where so say I'm looking at the verb discover. How close am I to the verb marry? Well, I can look at the distance, whereas the closer the distance, the higher the reward. And I can also look at how frequently the verb appears before the goal verb. So if it appears frequently before the goal, then it has a higher reward. And I multiply these two together with a constant, and I get decent, good results. So like the sequence, the policy gradient deep reinforcement learner achieves the goal like 95, almost 95% of the time, which is a lot more than the sequence just off on its own. And the perplexity drops as well, which is interesting because it shows that by adding this reward in, we're capturing patterns in the data that like regular cross entropy is missing. And the average story length stays about the same, maybe a little less. And so we can hit the goal the majority of the time now. But are these stories actually any good? Well, we asked people, because that's the only real way to actually evaluate a story. And we have this questionnaire of statements. We had a bunch of Turkers rate them on a 5-point Likert scale. And in particular, for this, we looked at the plausible ordering, if the sentences make sense given the ones before and after them, and if the story avoids repetition. And so here we got a bunch of results. To zoom in on the important ones. So, well, overall, the policy gradient didn't mess up what we got with the sequence to sequence. So we're not messing anything up, but we're also doing way better, like significantly better in the plausible ordering and the single plot, and also a bit better in the local causality. So now we have a model that can reach the ending. So far, I have a neural network that is more accurate because of these events and is now goal-driven. But they're still not causally coherent. So let me show you an example. So this is a story where it has the goal of hate/admire. And the story goes like, our sister died. Gregory executed during the visit. Gregory adopted the girl. The girl looked like her mom. She was appalled. Penelope detested the jungle gym. So it gets to the goal, but it's still really weird. And so I'm going to talk about how to make these stories more causally coherent. So to remind you about these causal chains, what makes sense about them is that they make sense, even if they're boring. And I can break it into pre and post conditions. So the pharmacist needs the prescription from the customer in order to produce, in order for them to check the prescription. But how do we get these preconditions and effects, or these pre and post conditions, when our sentences can be anything? Well, I used VerbNet to kind of dissect sentences into low-level semantic information. So here's like VerbNet 101. I say I have a sentence, Jen sent the book to Remy from Atlanta. I can get role information, such as Jen is the agent, the theme is the book, the destination is Remy, and the initial location is Atlanta. And I can also get like these semantic predicates, which show what happens over time. So at the beginning, the book is in Atlanta, has location in Atlanta, and at the end, the book has location Remy. And I also get information such as the agent has to be animate or an organization, the theme has to be concrete, and the initial location has to be some sort of location. These are called selectional restrictions. So what I do is I take the selectional restrictions and some of the first predicates, and I make them my preconditions, and then I move everything else to the effects, and I get rid of the stuff that happens in the middle that isn't as relevant. So going back, how does this fit into the joint system? So I'm actually focusing in on the event-to-event part again. So after I have my event, I feed it into this environment now. So I still have my sequence-to-sequence model, which I call my genre model, because it kind of gives the feel of the genre that you're working in. And I also have this world engine now that tells you what is possible. So the world engine gives me my current state, and the genre model gives me candidate events. So the current state is stuff like Remy has possession of a book and is animate, and the book has location Remy and is concrete. And the candidate events are just these events. So it could be like person 0 leave location 4 and so on. And I can have some type of event selector. So maybe a deep reinforcement learner that can select which of these candidates, once they're verified to be accurate, which one of these is the most appropriate to continue the story. So here's an example of some preliminary work that I have so far. So I'm going to start with the causal, so the joint system that I just showed you, that example first, and then I'll show you the baseline, the non-causal system, which is just the neural network. You can kind of see the difference. So with the causal system, you could see that it has these chunks of where the entity is found, but it's also distributed across the story. So Evelyn is in the 4th line, but she's also brought back in the 10th line. So it's not forgetting these entities. Compared to the non-causal system, which still has these chunks, but they're more isolated. So there's no, it's not as distributed. And you could do the same thing with GPT. So if I swap the genre model out with a fine-tuned GPT model, I can get full sentences. And so here's a story that we created. Christopher attacks Harriet. The king tries to take him away. Christopher is taken away, but is quickly saved by Aigner. The king is able to escape the tower. Christopher and Christopher are able to get Christopher out of the tower, where the tower is still on the king. Penelope and the king are able to save Christopher. So with the exception of this line, it's actually doing really well. It's being kind of interesting, and it's also making causal sense. And part of the reason why this sentence fails is because these long sentences are hard to parse with just VerbNet, which often gives you just very simplistic syntax templates. So I'd also like to mention that this work has been featured in a Wired article talking about this joint neural causal model. You can check that out later. So to recap, storytelling systems are important. So I'm not just talking about something that doesn't need talking about. So also I have separated semantics and syntax. So language generation can be longer and can be easily translated into other languages. I have controllability, which makes these language models able to solve longer term plans. And I now have a hybrid system for reasoning and maintaining state, which creates general systems that are consistent within themselves. So I don't know how I am on time, but I can talk a bit about my future plans. So now that we have all that I've done, we're ready to make a Dungeons and Dragons agent. dungeon master, right? Well, there's more to it than just causality. We can add in things like humor. We can make it which makes it entertaining. It builds rapport, and it brings attention to details. We can add in character interactions. We can create actions consistent to personality, dictate character actions based on relationships. We can also look at effective speech. So which creates deeper interactions and lets the agent appear more understanding. And it can also underline sarcasm that's often not detected in text alone. So, along with something called reincorporation and look ahead. So going back to this, the talk to transformer example, part of what was wrong is that there are a lot of loose ends. So I mentioned her owner, it mentioned his sword and this house filled with blood, and these are really interesting things that are just dropped. But if we can tie them up, we can make the story feel more complete. So if I change the hunter to her owner, it feels less like I'm leaving these entities behind. And this is less of a causal issue and more about reincorporating ideas that have been mentioned. So I'm reincorporating previously mentioned themes to tie up loose ends. And this might sound familiar to you. It's similar to something called Chekhov's gun, which says that if something is mentioned in the world, it's for a reason. And it's not an actual gun, it's a literary device. So it's like reincorporation, but more planning forward. And how would this system look? Well, I could have a collection of these deep reinforcement learner models with the goal of achieving topics. So this is my dog module. And then the system can plan through these. So it could say, okay, I'm at dog, I want to go to food, and then I talk about owner, and then sword, but then I mentioned food again. Okay, so I could check that off, that's reincorporated. So I should mention dogs again, and then that's reincorporated. And so it will make the story feel more complete. And as an example in a different domain, I could say we have in dialogue, a user talking to Siri saying, Siri, there's going to be 200 people at my wedding and they all need to eat. I need to order 30 tablecloths and 20 tables. And Siri says, okay, I found this party rental store near your venue. Did you want to book a caterer as well? So while the user can introduce things that now become part of the plan. And it's not like that the system can work on a single thing at a time. And I'm also interested in working on collaborative dialogue. So if we study human-centered collaborative AI, then we can create agents that can provide complementary skills and help guide the human toward a shared goal. We could use effective speech understanding to lead to more productive communication. And we can foster feelings of pride toward the final product through the relationship with the agent. And this is already built into the system. So going back to these hard problems, the infinite number of sequences and unexpected consequences, I looked at with events. And it could also, reincorporation can also look at the unexpected consequences. Reasoning addresses the dynamic continuous world and distributed world. The plot progression kind of fixes the intrinsic reward problem. And then there's the collaborative dialogue. All right, so that's all I have, and I have some little blips about some of the previous work that I've done, and I'd like to thank all the people who have worked with me, past and present. All right, thank you.
Thank you, Laura, for the talk. It was really cool, and
Thanks.
I felt like it's a good combination of what you have done and also what you plan to do and what is the scope for the field. I think that's really great. Thanks for introducing that
Yeah,
to us.
you're welcome. Yeah,
Um,
it's hard to I think it's hard to say like, well, I'm talking about storytelling, which is something you probably haven't thought about. So I feel like I need to give some context of like where the field can go as well.
yeah, that's great. Thank you. So let's go to the Q&A. And please post your questions in the Q&A chat or the event chat, and we'll we'll ask Laura the question. So one of the questions here is, I think this was sometime in the middle of the talk. When you say you extracted events from stories, do you mean preparing a new event data set?
Yeah, I am, but I also can extract events on the fly if I create like this like story loop, this interactive loop. But yeah, it's basically making a new data set for the event to event and event to sentence systems.
Okay, and I'm curious, so how many events are generally there? Like I said that there are like there's a goal, right? Hate or admire, like one of the goals that you have
Oh,
presented. So I'm just a bit curious about the setup, the story generation setup that you have that's there. Like how many goals are there in the data set? It is generally in the data set. And like, is it a lot, or are you looking at only certain specific plot sequences or
right.
goals?
So there actually aren't any goals in the data set. They're things that we determine are um, relevant to the
Mm-hmm.
genre. So like we were working with a romance type data set, so we
Mm-hmm.
decided
Mm-hmm.
admire would be an appropriate goal. And
Mm-hmm.
so by and so that's why we needed this fancy reward signal to give us to kind of twist the data set so that it acts more like all the stories end in this reward in a way. Um, and yeah, so we that just because we have a model that has a goal of admire doesn't mean all the stories that it's trained on end in admire.
Mm-hmm. That makes sense. And another question from Jin Fang. Did you use some off-the-shelf semantic role labeling or semantic parser tools to extract events and predicate argument pairs?
Um, extract events and predicate argument pairs. Well, so there, so the event extraction was done with a dependency parsing, and I used Stanford's dependency parser and a huge collection of rules um, to parse out the parsed. Um,
Mm-hmm.
uh, and so once I had that, but then there's also these semantic predicates which come from VerbNet, and VerbNet is a tool created from University of Colorado Boulder, um, led by Martha Palmer, and I worked pretty closely with them to kind of get because they had VerbNet, but they never really had an application for it, and so I tried to work with them to get it usable. um,
Mm-hmm. Mm-hmm.
and they created these semantic arguments. And so the way that works is that if I have a verb, I look that up and then I match it with, okay, what syntax does it match? And based off of the syntax, it gives me the semantic predicates. And so it's syntax based semantics, which isn't great, but it's something.
Mm-hmm. Yeah, some way to capture the events. Yeah.
Right. Or yeah, the
Um,
semantics from the events.
and we have another question from Professor Di Yang. When generating a long output, how should models take care of the writing styles in addition to content consistency?
Yeah, so this is like in general, but well,
Mhm.
but in my specific system, because I have these events, it actually lends itself to um, making writing styles pretty consistent because there's the event to sentence component, and in the event to sentence component, you can have maybe a special model that's like I want everything to sound like it's written by like a fifth grader or something. Um, and so you can translate these events into that fifth grader language, uh, and that will give you yeah. So the consistency is captured in the event to event part, and then the style is then in the event to sentence part. Um, yeah, I don't know about models in general. That's a complicated question, but yeah, that's how it works in my system.
Mhm. Let's go to the next question by Sarah. Hi, Lara. Thanks for the talk. How do you handle out of distribution prompts, such as a story prompt from a completely different genre than what the model is trained on? Do your tools improve the robustness of GPT output in these cases?
um, so when I do want to clarify that when we're using GPT, we're not using events anymore. And that's partly because uh, it we just couldn't get GPT to like cooperate with event representations. They weren't English sentences anymore, and so we thought we would leverage the full the the like the output of GPT and how it sounds more fluent. Um, and we combine that with the causal part, the world model. Um, but in terms of handling out of distribution prompts, um, it so there's no way for it to um, really understand completely out of distribution things. Uh, it could be that there was something from a different genre that had a very similar event because it's so generalized, there is that chance of having an overlap. But so far, I don't have a way of handling these completely out of distribution.
Next question is by Aaron Stewart. In collaborating storytelling, are these aspects of storytelling, in collaborative storytelling, are there aspects of storytelling that an AI system would be more equipped to handle? Example, coherence versus a human, creativity.
That's an interesting question. So, um, it, I mean, it depends on what kind of AI system you're talking about, because if so, neural networks are good at finding general patterns in data, but they can also be kind of more interesting. While a a like a planning based or a symbolic approach is more coherent, which could also lead into creativity if you define creativity as being uh, like useful, and you can think of coherence as being useful. Um, so, um, so I think that I'm gonna kind of step back and say that I think where story generation is going, or where it should go, is in aiding people to tell stories. So right now there's people who are working on like, what if someone has writer's block? They can prompt a system to come up with like this like really like if the human is thinking in a space over here and the system can generate something that's like way over here in this idea space. But so the computers are really good at searching very large spaces, but humans are really good at coming up with the connections between these ideas. So when someone sees this idea that's way over in the space, they can connect the dots and bring it into their own space. So there, which is also actually makes story generation tricky because sometimes people will read into these stories more than maybe they should. But yeah, it's really tough working with computational creativity.
Next question by Gia. Did you plan all the events first and then generate the actual stories? Will the generated sentences affect the event planning? Also, how to measure or decide what are the good plots in stories? Example, sometimes the incoherent plots might result in some humorous stories.
Yeah. So yeah, the way that we did it was the two systems were separate. It would generate all the events and then translate them into like English sentences. And so we actually did run into a lot of issues across the models, because a lot of times the event-to-event model would generate something that the event-to-sentence model has never seen before and is not even close to what it was trained on. And we never really countered that. More recently, I've been seeing stuff about how people joint train models so that they make more sense together. But so looking at good plots, humor is really complicated because, like, just because something's unexpected doesn't mean it's funny. And so that's a really fine line to walk. And computational creativity, I don't think is anywhere close to that yet. It can maybe handle puns, but beyond that, if it's funny, it's by mistake. So the only way that we really have to measure these stories is to really just ask people, like, did you enjoy this? And like I showed there, we have these statements that people can rate these stories on, and that way we can see, okay, well, this model is definitely better than this model, but that doesn't really tell you, like, well, was this model actually any good? I mean, by itself, that's an open question.
Makes sense. Next question is by Andrew Silva. Are there ways with this system that we could regulate the emotion or feel of a story, like making the ending happier or sadder?
Yeah, so actually there is someone in the lab, my advisor is Mark Riddell, in Mark Riddell's lab, who's working on poetry generation and trying to alter the ending of the story, of the poem. But there's also people who have worked on, okay, I want this story to be about, like, have these like kind of keywords in it. And so there are ways with this system and other systems, I think, could kind of regulate the emotion. The system would need, kind of going back to that there was one of the previous questions is talking about the writing style. So I think it kind of feeds into that. We would maybe it would be like creating a deep reinforcement learner in the an event to sentence part, which we haven't tried. So that could be really interesting. But I don't know if that would work. I'm just brainstorming right now, so maybe that's dangerous.
I think it's good to hear your thoughts, right? You're the expert in the field. Next question is by Pradyumna. Hey, Lara, do you think there's any modifications to your pipeline that can encourage or regulate creativity similarly to genre?
Really similar. I'm trying to think of what regulate creativity, encourage and regulate, but not genre. Sorry, I'm a little stuck right now because it's like think of anything but elephants, and I can only think of genre. So did you have anything in mind?
Pradyumna, do you want to type if you have
Yeah.
anything in mind in the event chat? I think that's the problem a bit with the chat.
Yeah, I know that sometimes there's a delay too. So
Yeah. Okay, maybe you can assume something.
Yeah, well, I mean,
Answer.
I think so. If you want to encourage creativity, you can think of something kind of like what I was saying about like offering ideas in a space that's like outside of what they're normally thinking of. But you don't want to do that in a completely random way because that's not useful. So it's I think that I don't think that my system in particular is set up to because it's not set up to like encourage or regulate someone else's creativity, but it can be regulated itself. But yeah, so I would go towards something that was that would find some kind of connection between ideas, but then take like a hop away or something. I know this is really abstract.
I think he has a comment now.
Okay.
I didn't mean in spite of genre. I just meant being able to make a story more or less creative.
Oh, okay.
Yeah.
Yeah, okay, yeah. So making a story more cre- yeah, so I mean the way that I am going about that is just by trying to make it more creative, where I am defining creativity as novel and useful. Um, and I know that like people can have different definitions of creativity, and it depends on how you define creativity as well. But yeah, so I think we want it to be more creative. I think if we can easily make less creative systems because we can just repeat a story that we've heard before. That's completely uncreative. So I think the challenge is making things more creative.
And I think these are the questions. I think we're just about the right time, 1:30 correct time.
Well, yeah, thank you for all the great questions.
Yeah, thanks everyone for posting so many questions. Actually, we had a lot of questions today. And thank you so much, Lara, for your amazing talk and
Yeah, no
sharing
problem.
your work with us. And we'll meet 2 weeks from now. again for the next NLP seminar by Ein Stewart. So hope to see you all again. Bye.
Bye. Thank you.